Your local AI agents are incredibly powerful, but they are currently trapped in an operational vacuum, completely isolated from your company, proprietary knowledge assets, and critical long-term corporate records. Stop settling for generic model outputs that dilute brand value and start feeding secure enterprise data directly into your automated workflows to maximize competitive advantages and digital scaling efficiency. Today, we demonstrate the advanced implementation strategies required to successfully bridge that structural gap using the Open Model Context Protocol developed by frontier technological institutions like Anthropic Research. It is May 2026, and if your technical team is not mastering this framework, your entire artificial intelligence infrastructure is already falling dangerously behind global enterprise efficiency standards. We have officially moved past basic engineering tutorials because modern architecture requires high-level native integration that directly connects localized model intelligence to massive, highly secure corporate data ecosystems. This executive technical briefing delivers the practical production-ready steps your enterprise decision-makers have been asking for to safely revolutionize current data connectivity models without incurring massive cloud overhead. Imagine giving your local autonomous artificial intelligence agents safe, real-time access to every critical corporate spreadsheet database and confidential document across your global infrastructure with strict administrative oversight. This is a highly comprehensive masterclass explicitly designed to transform isolated digital bots into enterprise-aware organizational powerhouses capable of executing complex, contextually grounded workflows at absolute maximum scale. Later in this strategic executive briefing, we will reveal the precise framework to mitigate capital expenditures and effectively manage the underlying infrastructure costs of these high-performance local integrations. Let us dive straight into the sophisticated model context protocol techniques that will completely redefine your corporate data connectivity paradigms and unlock unmatched automated efficiency across your company. To understand the necessity of this protocol, we must evaluate how enterprise data house structures have traditionally functioned under classical decoupled software integration models over the past decade. Traditional enterprise methodologies relied heavily on customized corporate application programming interfaces, which required endless manual coding maintenance and created severe performance bottlenecks during intensive real-time information processing routines. When local autonomous agents attempt to query vast unstructured organizational databases without a unified abstraction layer, they encounter profound context windows limitations and produce highly unreliable semantic outputs. This severe structural disconnect forces modern corporations to continually rely on expensive external cloud infrastructure, transferring sensitive proprietary data outside localized servers and increasing corporate financial exposure significantly. According to technical research reports from leading machine learning entities, model fine-tuning alone cannot resolve real-time data discrepancies because corporate records change much faster than training cycles accommodate. Therefore, a universally standardized communication protocol is absolutely required to establish a secure client-server relationship directly on local devices, allowing models to discover available data resources dynamically today. The Model Context Protocol addresses this by decoupling the data source architecture from the core algorithmic logic of the underlying large language model operating on the executive desktop. By utilizing a standardized JSON RPC architecture over local command line interfaces or transport layers, software developers can implement unified schemas that expose tools, resources, and prompts without rewriting code. This absolute modularity ensures that if your data stack updates from an old SQL framework to a modern vector database, your local agents do not require expensive re-engineering. Instead, the designated protocol server acts as an intelligent translation layer, mapping corporate assets into clear context formats that any modern advanced algorithmic intelligence can easily parse immediately. From a corporate strategy standpoint, This architecture mitigates massive operational expenses by shifting from continuous cloud computing dependencies to localized client-side infrastructure processing models with very high efficacy. Organizations can keep their proprietary insights inside their secure corporate firewall, entirely eliminating external data governance risks, while empowering internal developers with ultra-fast context retrieval for advanced applications. Data literacy within your enterprise workforce accelerates naturally as local agents become contextually hyper-aware of internal institutional processes, project histories, and complex historical compliance metrics across global departments. This aligns directly with global digital transformation trends that prioritize decentralized edge intelligence over completely centralized hyperscaler infrastructure, thereby mitigating monopolistic vendor lock-in risks for modern business units. Let us now examine the precise mathematical logic and programmatic interactions occurring between the protocol host applications, client configurations, and underlying enterprise data repositories during active live operations. Under the official Model Context Protocol specifications, the architecture operates through three primary primitives, which include resources, prompts, and customizable tools designed for autonomous structural corporate file execution. Resources represent the data reading capability, allowing your local intelligence layer to seamlessly ingest text schemas, document content, database tables, and system application metadata via uniform resource identifiers. Prompts serve as standardized templates, allowing your corporate development team to deploy unified command logic across multiple distributed departments, ensuring alignment with corporate operational guidelines and performance standards. Tools represent the actionable write mechanics, enabling local agents to dynamically execute terminal commands, modify secure local records, update internal databases, and trigger approved external API pipelines autonomously. When a user triggers an interaction, the host application, which acts as the primary orchestrator, sends a structured inquiry payload containing highly precise parameters to the designated server. This server processes the incoming parameters, translates them into system-specific queries like structured database lookups, and returns a clean, standardized context wrapper back to the active local client. Because this entire communication sequence occurs through local standard input and output streams or localized transport webs, the actual transfer latency remains incredibly low, maximizing total processing velocities. Resolving our earlier operational cost loop requires acknowledging that localized execution completely eliminates data egress charges and expensive per-token subscription rates charged by proprietary centralized corporate service providers. By processing data locally via optimized open weights models, your operational budget shifts smoothly from recurring operating expenses to highly predictable internal capital assets and controlled storage infrastructure investments. To implement this framework, practically, your software engineering teams must first deploy a dedicated protocol server built using the official software development kits available in Python or TypeScript. This custom server configuration will define the specific data connectors, mapping files, folders, databases, and communication endpoints that your local autonomous agents are authorized to access during workflows. Next, you modify your host application setup, which could be an open developer desktop setup or a tailored enterprise interface, to recognize the newly configured server connection string. Upon initialization, the host and server execute an immediate technical handshake, exchanging structural capability schemas and registering all available analytical tools, resources, and command configurations for immediate execution. When the local model encounters an objective problem requiring external knowledge, it dynamically reviews the registered tool schemas and selects the exact method needed to fetch relevant data. For example, if an executive asks for a regional revenue summary, the model calls the localized server tool to extract sales figures directly from an isolated on-premise spreadsheet. The retrieved data payload is injected cleanly back into the context window, allowing the agent to formulate highly accurate corporate reports without routing information through public network lines. This design completely eliminates the historical reliance on complex middleware architectures, simplifying corporate software environments and ensuring long-term technological agility for engineering squads attempting to scale internal automation. Corporate decision-makers can comfortably govern data definitions at the server tier while allowing multiple distinct local model iterations to connect freely and read context data without friction. This architecture establishes a highly robust, future-proof ecosystem capable of absorbing upcoming advancements in generative model capabilities without requiring teams to overhaul existing internal operational data storage configurations. Let us now transition directly into threat modeling and security configurations to ensure this local connectivity pattern adheres perfectly to strict, zero-trust standards and modern international cybersecurity parameters. While connecting local agents directly to proprietary data maximizes efficiency, it introduces new internal threat vectors that enterprise security teams must actively identify and mitigate through structural controls. Unrestricted tools access could theoretically allow a compromised agent to read unauthorized database rows or modify sensitive master configurations, creating severe inside systemic compliance risks across your networks. To enforce strict defensive parameters, corporations must align their local model deployments directly with established frameworks, like the comprehensive NIST AI Risk Management Framework, to guide safe orchestration. Security architects must implement precise zero-trust validation layers, requiring every single local model interaction to be explicitly authenticated and authorized before data resources are exposed to the agent. Protocol servers should always operate under the absolute minimum privilege model, ensuring that an autonomous agent can never view or modify data outside its designated functional corporate scope. Furthermore, continuous telemetry streaming and deep system logging must be actively configured on all local transport layers to immediately detect unusual query patterns or unauthorized data transmission behaviors. By containing server execution within isolated local software wrappers or container units, security professionals can block an algorithmic intrusion from spreading into broader critical corporate network infrastructure components. Regular automated auditing of the protocol schemas always ensures that obsolete tools or forgotten data access permissions are systematically revoked before they turn into vulnerable system entry vectors. This layered defensive strategy safeguards your organization's intellectual property while unlocking the full revolutionary potential of localized artificial intelligence models without exposing corporate databases to external cloud breaches. Balancing rigid risk mitigation frameworks with agile application development always ensures your technological transformation initiatives remain entirely compliant with evolving global security parameters and enterprise data governance expectations. Mastering the Model Context Protocol is no longer just an optional experimentation track, but a fundamental cornerstone of modern production-grade corporate artificial intelligence engineering architectures across global sectors. By bridging local agents directly to proprietary data securely, your enterprise can drive localized workflow, automation, mitigate excessive cloud compute overhead, and maximize total corporate return on investment. Ensure your internal engineering squads begin building dedicated protocol servers, immediately utilizing open standard tools, and enforcing rigid defensive security practices to safeguard critical corporate assets very systematically. The future of scalable organizational knowledge requires secure, localized context integration, which you can easily deploy today by executing the advanced technical architectural blueprints outlined in this briefing. To ensure your leadership team maintains a definitive competitive edge throughout this rapid institutional digital transformation, subscribe to AI Knowledge is Power to lead the digital future.